Let's keep going here with example 8. We have that f of x is equal to the cubed root of x plus 1. So again, start by identifying the basic shape. So we have the cube root of x, and the cube root of x is one of those that looks like a stretched out s, and it's got key points that are going to be in opposite directions. Next, do you have a vertical shift? Well, let's check. Yes, I do. I'm adding 1 to the function, so my vertical shift is up 1. Do I have a horizontal shift? Is there a number that I'm adding or subtracting to the x? Again, this is a radical. Is there a number inside that radical with the x? No, there isn't, so I don't have a horizontal shift. Figuring out the vertex from here, remember the x and the y. My vertex is going to be 0, 1. Let's plot that on the graph. Next, I look for the compression stretch. Am I multiplying this function by a number? Well, there's no number out there, so again, I can always put 1. And now, let's find those key points. This tells me I need to go up 1. I'm not reflected, so I'm going in the normal basic shape of the cube root function. So from this vertex, I need to go up 1, right 1, and then I need to do the complete opposite. So up, right, then I need to go down and left. Remember, with these cubes and cube root functions, you have to do one key point and the complete opposite for the next one. So again, from that vertex, go down and left. Finally, I'm asked to find the x-intercepts, if any. So I set the function, the cube root of x plus 1 equal to 0, and I solve for x. Subtracting 1 from both sides, I get that the cube root of x is equal to negative 1. Let's cube both sides to solve for x. Cube root of x cubed is just x, and negative 1 cubed is negative 1. These aren't the kind that you need to check, so let's go ahead and just say that our x-intercept is x is equal to negative 1. And if we look here, we actually already had that point on the graph. Finally, just connect it, having the same basic shape as our cube root function. Let's keep going. Example 9, same thing. Absolute value of x minus 4 plus 2. Basic shape, absolute value function, so that is my v. And the key points for the absolute value are both in the same y direction. So they're both either up and left and right, or both down and left and right, depending on whether or not we're reflected. Do I have a vertical shift? Well, yes, I do. I'm adding 2 to the function, which means I go up 2. Do I have a horizontal shift? I look here. I do have a horizontal shift. My horizontal shift is right 4. Remember, it's always opposite the number with x. So the vertex for this particular function is going to be positive 4, positive 2. Let's graph that. Next, compression stretch. Am I multiplying this function by a number? No, there's no number out there, so I can always write 1. Well, because it's not reflected, I know that this tells me that I need to go up and left and up and right. And remember, it's up and left and up and right because the key points for the absolute value function are in the same direction. So again, from this vertex, I need to go 1 up and 1 to the left. Again, back to the vertex, 1 up, 1 to the right. Finally, the x-intercepts. Let's see if we have any x-intercepts here. The absolute value x minus 4 plus 2 is equal to 0. Subtracting 2, I get that the absolute value of x minus 4 is equal to negative 2. Well, when the absolute value is equal to a negative number, we know that's no solution, so we don't have x-intercepts, and we would write none. Let's go ahead and just graph this, connecting the points to make sure we look like our basic shape. And if we look at this, it makes sense that we don't have x-intercepts because we will never be crossing this x-axis. Alright, the last one that we're going to graph here. So we have f of x is equal to 3 halves times the cubed root of x plus 4 minus 3. What is the basic shape of this function? Cubed root of x, which means that I look like that stretched out s, and I know that my key points are going to be in the opposite direction of each other. Next, vertical shift. Do I have a vertical shift for this function? Let's see, I am subtracting 3 from the function, so I need to go down 3. Do I have a horizontal shift for this function? I look here, there's a plus 4 underneath the radical with x, so remember that's always opposite your intuition, so you need to go left 4. Do I have a horizontal shift? Yes, I do. I'm adding 4 to my x. There's a 4 underneath that radical with the x, which means I'm going left 4. Remember, it's always opposite the number with x. So the new vertex for this function is going to be negative 4, comma, negative 3. Let's go ahead and plot that. So here's negative 4, negative 3. Do I have a compression stretch? I do. My compression stretch is 3/2. So my compression stretch is 3/2. It is not reflected, so I know that I'm going to go in the same direction as my key points. Remember, these key points are both opposite directions, so one is going to be going up and right, and the other one's going to be going down and left. So let's graph those key points. Again, from this vertex, I need to go up 1.5, because 3/2 is 1.5, and right 1 unit. And then I need to go down 1.5 and left 1 unit. Again, let's take a look at that. From the vertex, I go up 1.5 units and right 1. Again, from the vertex, I do the complete opposite. I go down 1.5 and left 1. Let's see if we have any x-intercepts. Let's set the function equal to 0 and try to solve it for x. So I have 3/2 times the cubed root of x plus 4 minus 3 is equal to 0. In order to solve, I need to start by moving that 3 to the other side. So I get that 3/2 times the cubed root of x plus 4 is equal to 3. Let's clear the fraction first, so multiply both sides by 2. And I get that 3 times the cubed root of x plus 4 is equal to 6. Divide out my 3, because I need to isolate the radical, and I get that the cubed root of x plus 4 is equal to 2. Cube both sides to solve for x, and I get that x plus 4 is equal to 8. Subtracting 4 from both sides, I get that x is equal to 4. Again, these aren't the kind that we need to check, so we know that our x-intercept is 4. All right, those are all our points. So what we need to do now is graph it, making sure that we have the same shape as our function. And there we go. That was the last graph that we're going to do. Now let's go ahead and just start talking about even and odd functions. So the last bit of this section talks about even and odd functions. And even and odd functions are much like symmetry, but we're really looking only at symmetry to the y-axis and symmetry to the origin. So let's take a look at this. A function is considered even if you can plug in a negative in place of x and end up with a function itself. A function is considered odd when you can plug in a negative in place of its x and get the opposite of the function. So, how do we determine if a function is even, odd, or neither? What you do is you plug in a negative x in for x and simplify the expression. If the simplified expression in step 1 is equal to your function, then you're even and you're all done. If it's not equal to your function, you need to find the negative of f of x, which means you just multiply the original function by -1. If the expression in step 3 matches your expression in step 2, then your function is odd and you're done. If none of the functions match, your function is neither odd nor even. So let's go ahead and take a look at if these functions are even, odd, or neither. So the directions are to determine algebraically if the following are even, odd, or neither. So let's go ahead and start with the first one. So step 1 says plug in a negative x for x and simplify my function. So I'm going to find f of negative x. Well, this is just a function value, and it tells me everywhere there's an x in my f of x, I need to plug in a negative. So I'm going to write 3 times negative x minus negative x raised to the 3rd power. And let's go ahead and clean this up. Well, 3 times the negative x is negative 3x, and the negative x cubed is a negative x cubed, so this just stays as negative x cubed. Well, negative and negative, we know that that is a positive, so the f of negative x, when it's cleaned up, becomes negative 3x plus x cubed. Step 2 says, if the simplified expression from step 1 equals your function, is this function the exact same as that function? No, it's not. That's 3x minus x cubed, and this is negative 3x plus x cubed. So I'm not even. So now I need to figure out if I'm odd. The way to do that is to multiply, step 3, your original function by a -1. So let's go ahead and multiply the original function by a -1. So I'm finding the negative of f of x, which again means just to multiply the original function by -1. If I do that, let's distribute my -1 in. I get negative 3x plus x cubed. If this is equal to your expression from step 2, so are these two functions the same? Well, yeah, actually these two functions are exactly the same. They're both negative 3x plus x cubed. Well, then that means that I am odd. this function is odd. So you're just going to do this until you find out if you're even or you're odd. If you're not any one of those, you're neither. So let's look at the next one. First thing I do, I find f of negative x. So I'm plugging in a negative x in place of my x. So I write negative x squared minus 3. Clean this up. F of negative x is equal to, well, a negative x squared ends up just being positive because I'm squaring it, minus 3. Does this function match my original function? Yes, they're exactly the same. F of negative x is now the same as f of x. Because they're exactly the same, I am an even function. Since I found out I'm even, I'm all done. I move on to the next problem. I have f of x is equal to x squared plus 2x. Step 1, find f of negative x, which means I'm going to plug in a negative everywhere there's an x in my f of x. So I say negative x squared plus 2 times negative x. Let's clean this up. Well, a negative x squared is just x squared, and 2 times negative x is negative 2x. Does this simplified function match my original function here of x squared plus 2x? No, this is minus and this is plus. So step 3 says, all right, we'll find the negative of f of x. So multiply your function, the original one, this guy up here, by negative 1. So I want negative 1 times x squared plus 2x. If I distribute in my negative 1, I get that negative f of x is equal to negative x squared minus 2x. Now, does this function match the function of f of negative x? No, because this is a positive x squared and this is a negative x squared. That means I'm not odd. So if I'm not odd and I'm not even, I am neither. That's it for this section on transformations of functions and even and odd functions.